All right, Anisa and Safrina, let me start with the backup class. See, the first chapter will be going in the sequence. So I'll just suggest you separate this register. Okay, don't mix it in the one which we have already, which we are doing, because see, these classes will be on some days on and off. Okay, but your classes there will be regular, so that shouldn't be disturbed. This will take time. We'll cover all the chapters what are missing. I think Safrina, you joined from the fourth chapter.
Yes, ma'am.
Okay, and Anisa did from the fifth. Okay. See, I'll go slowly only the way we go in the classes. It's just that, see, for the theoretical part, just take the screenshots because let's not waste time in writing here. Okay. So for the questions, make a register. Just take a rough register. That will also do good. And then you can copy down whatever screenshots you have taken after the class, because see, after today, the class will be on Monday. So you will get a time to revise, and I'll not hurry up. We'll not just go on with that. See, you have the units, which is electrostatics. Okay, this unit first is the electrostatics unit. Electro refers to electric charges. Okay, this is not for electrons. This refers to electric charges. So electric charges. Now, statics means something that is at rest. So electrostatic means electric charges are at rest. Now, whatever concepts we'll study, these concepts we'll keep in mind that we have the electric charges are at rest. Okay, the concepts that we were studying in magnetism and the other concepts, all the rest of the concepts, they had this thing that a charge was moving, whether it was giving rise to magnetic field or not. So here, whatever will happen, a charge is not having any velocity. When the velocity will come, we'll study it in separately in current, electricity and all. Right now, the conceptual part is that we are studying electrostatics. Okay. So the basic thing that we start with in electrostatics, that is your electric charge. Without this electric charges concept, you'll never be able to understand anything of electrostatics. Intrinsic property of matter that gives rise to the electrical forces. This basically means intrinsic means something that is inside the smallest part. Like we say, intrinsic property of matter are the atoms, like this we say. And what's the intrinsic property of an atom? Those are the electrons, protons, neutrons. Intrinsic means something that is inside. So the innermost property of the matter. Now, innermost property could be anything, atoms, molecules. So what are we referring to? We are referring to the electrical forces, electric field and all. Like if you have an electric charge, it gives rise to electric forces. Forces give rise to electric field. Electric field give rise to potential. Potential will give rise to potential energy. That will give rise to capacitance. That there's a whole lot sequence. Then the charge will begin its motion. Then you will have the current in your system. Current will give rise to magnetic field and magnetism and matter and everything. Then electromagnetic induction combined. So many things are there. But how did it start? It just started with this single quantity electric charge. So it's basically the fundamental quantity of your entire electrostatics. Okay, that's the thing that you need to know. What else you should know? SI unit. SI unit is very easy of electric charge. Tell me.
Coulomb.
Coulomb. Very good. Electric charge is very easy. You should just remember Coulomb in here. This is Coulomb. Okay, do you know the CGS unit as well? Anyone? CGS unit of electric charge. Like this is the SI unit, CGS unit. See, I'll tell you this, CGS unit of electric charge, this is actually used least. Like your Gauss is used often in the magnetism, but electrostatics charge unit is used least. See, this is known as stat coulomb, or the most common one, this you'll find it really. This one you will find electrostat unit. This is written as ESU. Okay, this is the CGS unit of the electric charge, electrostat unit, written as ESU. Like if you want any conversion, just in case if you see any question, I'll tell you the CGS unit is not a very common unit which has ever come in your board exams at least. But just in case, because CGS unit and SI unit are the basic things, 1 coulomb can be written as 3 into 10 to the power 9 electrostat unit. You can always use this conversion to convert the SI unit into CGS or CGS into SI. Now, basic thing, what are the types of charges? We already know there are two kinds of charges. So one is the positive group of charges, other is the negative group of charges. Okay. Now, this was discovered by the scientist Benjamin Franklin. That time the charges weren't known. That time electron was also not known. It was just that he was conducting certain experiments and he could conclude the fact that yes, two groups are there. He could observe two kinds of groups are there. Like, why could he observe it? The reason was positive, positive, negative, negative. They will repel each other, and positive, negative, they'll attract each other. So because of this basic concept, he was able to identify. But that time electrons weren't discovered, protons weren't discovered, these things weren't there. So it was difficult for him to identify what is this. But he could just observe that yes, two kinds of groups are formed. Now, what are these groups? Later on, when J.J. Thomson, Rutherford, all these did their experiments, it was observed that these are electrons, protons, neutrons, and how the structure of an atom is developed. So randomly he named one group as positive that time, and randomly he named the other group as negative. Like, this is arbitrarily written. This has no basis. One is positive, one is whatever came to his mind that time. He just mentioned the group as it is. Like, if it could be A group, he would have written. If in during that time in his head it was north and south, he would have written north and south. Okay, so positive and negative groups were formed. Am I clear till here? Okay. Just do one thing before this. Just take the screenshot of the syllabus also and these portions, okay? And just let me know done once taken. Just do one. Type in the chat box when both of you say done, then I'll. Just give a minute, as I'm just coming in a minute. Please wait. Yes, class. Sorry. I'm here. Just pay attention again, Safrina and Anisa. See, there's a little concept about the conservation of charges that you should know. Conservation of charges means positive and negative charges, they can never be created. They will be just transformed from one body to another body. Okay. So there is a minimum charge that exists. See, electrons are different, charges are different. Electrons are entities, they are particles that contain charges in them. Okay, one electron is there and it will have some amount of charge. So the minimum amount of charge that is existing in one electron is minus 1.6 into 10 to the power minus 19 coulomb. And in one proton, this will be plus 1.6 into 10 to the power minus 19 coulomb. So what's the minimum form? Minimum charge that is existing is plus minus 1.6 into 10 to the power 90 minus 19 coulomb. Plus minus depends upon whether it's electron or a proton. So this is often represented by the symbol E. You will see this symbol till your last chapter, semiconductors. This wasn't there in class 11th. So this is known as electronic charge. This is called as the electronic charge. Electronic charge means the minimum charge that is existing on a single electron and a single proton. Okay, which is 1.6 into 10 to the power minus 19 coulomb. Okay, so this value you have to remember because it won't be mentioned and it's very easy to remember because most of the conversions that you will be doing. One more thing, class. See, just understand a little bit about the movement and transfer of electrons. How the transfer of electrons occur, then you will be able to relate these points. See, around every nucleus, there are orbits present. And in these orbits, single electrons are rotating, revolving, not rotating also, angular spin also we did in magnetism. So they are rotating also, but they are revolving also. So basically two kinds of forces are here. Okay, two forces are here. First force that is present is within the nucleus, which we'll do in the nuclear chapter. This force is known as the nuclear force. And the characteristic about this nuclear force is that this nuclear force is a very strong force in nature. The nuclear force is a very strong force in nature. The next you have is the electrons. And how are they connected to the nucleus? So electrons and the nucleus, they are basically connected through electrostatic force. A little bit about structure of atom you've already studied in your class 11's chemistry. I think chapter 2 was there in class 11. So some things will be here again back in class 12 because that was also a part of quantum physics only. So here, how are the electrons attached to the nucleus? This is your electrostatic force. Okay, the force that acts here is the electrostatic force. Now, this force is a weaker force in comparison to your nuclear force. Like if I give you the statistic, the nuclear force will be 100 times than the electrostatic force if we take up the ratio. So this is how much they differ. Okay, so you tell me if in the nucleus the protons and neutrons are held tightly because of the strong nuclear force, and while the electrostatic force is weaker, you tell me which particle will be easily escapable? Like electron will be easily able to move or protons? What do you think? Yes, class, what do you think? Your electrons will be easily movable, like if some external force is there, which will be easily escapable. Like electron, it would be easy for electrons to move or easy for protons to move. Electrons, very good. See, the nucleus is holding the protons and the neutrons very tightly within the nucleus. So it will be difficult for the neutrons and the protons to escape because the force is strong. While this electrostatic force is a weaker force. So the electrons, this force getting cut is easier. It's basically the transfer of electrons which occur, that occur. Transfer of electrons that occur. And this whole process is known as charge. Not the charging that we do in current electricity. Charging means transfer of electrons. Electrons are getting moved, okay? And remember this properly, that protons do not move. Don't think that the protons move, okay? Protons do not move, electrons move. Like if an atom is there, lots of electrons are getting added to this. We'll say this is a negatively charged body. If lots of electrons are getting away from this atom, we say this is a positively charged body. It's not that protons are getting added into the atom, we say, okay, this is positive, okay? And when positive and negative are exactly equal, we say the body is a neutral body, okay? And see, the real picture I'll show you. This is how actually this part is the nucleus. Protons and neutrons are there, while the electrons are revolving like this. The actual orbits look like this. And in each orbit, a single electron is there, which is revolving around. Am I clear till here?
Yes.
Just one thing. Take this screenshot of this part as well and type. Okay. See, let's come to this charging, a little bit about this concept of charging. So charging means the transfer of electrons, okay? Now some more points about the positive and negatively charged body. If I give you a little example, here these are 4 electrons and I'm representing the nucleus like this, okay, with 4 plus sign. So because it's difficult not to understand it without the diagrams. So if I calculate the charge on this body A, plus 4 into what's the charge on a single proton? It's E. So 4 protons, 4E will be the charge. Similarly, 1 electron has the charge minus E. So 4 electrons in this atom will have the charge minus 4E. So plus 4E minus 4E total, the net charge is 0 on this object. And directly also you can see that positive charge is balancing exactly negative charge. So this body is known as a neutral body. Now look, if I talk about the electrons, remember electrons are not massless entities. Electrons carry their own mass, 9.31 into 10 to the power minus 31 kg. This is the mass of an electron. If 4 such electrons are there, 4 times the mass of electrons will be here. Now let's come to body B. Suppose one of the electrons from another atom is being added into this. Now, if I calculate the net charge, let's see mathematically, are we going correct or not? If I take the net charge over here, 4 protons are there, 5 electrons are there, plus 4e this time, but minus 5e. Plus 4e minus 5e makes it minus e. Minus means this is a negatively charged body. And we can see also excess of electrons negatively charged. But what you have to notice is 5 electrons will cause 5 times the mass of a single electron. Mass has increased. Charges have increased. So the mass also of the atom, the net mass of the atom will also increase. Let's talk about this atom C. Let's say 1 electron has been removed from it. Now when I calculate the net charge, plus 4e, and this is minus 3, that gives plus e. Plus means this is a positively charged body. Now 3 negative electrons, we can directly see there is deficit of electrons. And the mass is also 3 times the mass of electrons. So 3 times the mass of electrons mean the net mass of the body is decreasing. So for positively charged and negatively charged body, what all things you have to remember as a conclusion point, it have come in your board exams, okay? Though from this portion, few questions only come, and that too in the MCQ. Still now what we've observed, from methods of charging the questions come, that I'll teach you in today's class itself. For negatively charged body, remember 2 points, class. One, that it is formed by addition of electron, okay? Or this is formed by gaining of electrons. And second most important point, this has come in one of the MCQs of the board exams recently. In 2023's paper, what happens to the mass of the atom? The mass of atom increases. Okay. Now you have positively charged body. In positively charged body, it is formed by loss of electron, and mass of atom decreases. Now tell me, this part is clear? Anisa?
Yes, ma'am.
Okay. Now, see, there are 3 methods of charging. You can take the screenshots later. Let me discuss this part first. There are 3 methods of charging. Now, as I discussed with you, charging is not the electrical charging, charging of laptop phones and all. This is transfer of electron, because that I don't know why this term was given, but it is confusing with the charging. It seems as if we are adding electrons. So this is not the current electricity charging. Here, charging means transfer of electrons. It can be from any body to any body. So it is just the transfer of electrons. So there are 3 methods which you have to know. There are various other methods as well, but you just have to know these 3 methods. Charging by friction, charging by conduction, charging by induction. Friction is the least important in out of all of these. Charging by conduction is very, very important for your Coulomb's laws question also. Okay, I'm just telling you an overall view so that you just have an idea what you have to focus more on, because we haven't discussed these chapters, no? So charging by conduction, Coulomb's law, it will be used a lot. Coulomb's law and electric field. Separate questions also come, but its applications are more. Charging by induction is also very important in your capacitance. Throughout the principle of capacitor is induction only. And many questions come, especially this is important for students who are preparing for entrances as well. Okay. These are the methods of charging. Now I'll start with the first method, then you can take the screenshots because we'll be doing the numerical. Friction force in class 11, you must have studied. What do you remember about the friction force? Could you just tell me a little bit of it even, if you remember? Whatever was it in class 11th, it was there. Work, energy, and power. Before work, energy, and power, and laws of motion, friction force is there. And friction force is a very common force that we use. So what is it? Safrina, Anisa, anything that you can say of friction force? Nothing. Something must be there in your mind when friction term comes. Yes. You remember nothing about the friction force. Something must come to your mind. I don't want a perfect bookish definition. Just tell me 1 or 2 points also. That will do good. Just 1 point even that is coming in your mind. I have written 1 point here. You could have read it from here. It opposes the motion. This always acts in opposite direction to the motion. It's basically a contact force that occurs when 2 objects are rubbed against each other. So friction force acts in opposite direction to that of the motion. Okay. Now, whatever you studied about friction in class 11, it will be as it is applied here with just a little additional information that whatever is the work done against this force, friction is also a force. So whatever is the work done against this friction force, the valence electrons get transferred from one body to another. Like there are 2 objects and we are rubbing these 2 objects. Heat is produced, work is done. Work done will lead one valence electron of this atom to go into this. Valence electron, I hope you know in chemistry, the outermost electron, last electron of the shell, this is known as the valence electron. So it helps, it's exiting from the atom and it enters into the next one. So this is what is transfer by friction. Work is done against the friction. It means valence electron of the atom gets transferred when we rub two bodies together. Am I clear? Anisa, what about you?
Yes, ma'am.
Okay. Now, just a small concept that I'll tell you. Possibility of a question from friction can be from this part only, which I'm going to tell you. So there are two atoms. Can you just tell me, Safrina, for the first atom, what's the net charge on this body?
0.
0. Very good. This is plus 4e minus 4e. This is 0. Is it positive, negative? What is it, Safrina? Positively charged or negatively charged?
Neutral.
Neutral. Yes, it is neither positively nor negatively. This is a neutral. Okay, Anisa, let's come to you. Anisa, tell me the net charge of this body.
Ma'am, 0.
0. Very good. It is plus 5e minus 5e. This is also neutral. So we
Neutral.
have to, yes, this will also be neutral. Very good. So see, both of them are neutral. If I give you one condition, if I give you this statement, this which is written here, B has strongly bonded electrons. Now, what is meant by strongly bonded electrons? Means electrons are tightly held. The force, if we compare these force and these, means these two forces, this force and this force, this one is strongly bonded. So now tell me, both of you, from where electrons will be easily able to move? From A to B or B to A? B has strongly bonded electrons. What do you think?
A to B.
A to B, very good. Because here the weaker bondings are there, it will be easier to remove this electron. Electrons will be transferred from A to B. This is how the electrons are getting transferred. If this is how this is getting transferred, this leaves the object A to be deficit of electrons because electrons are moving out. So what's the sign here? Is it positive or negative?
Positive.
Positive, very good. And this will be negative. So questions from charging by friction come in this manner that you have to decide what's the sign of the body. A condition will be given to you, or if sign is given, then reverse. If I give you the sign, A is positive, B is negative, and I ask you which is strongly bonded, immediately it should come to your mind that B must have strong bonded electrons because it is not losing its electrons, it is gaining electrons. This is the whole concept behind this, and that's the maximum possibility if a question from charging by friction comes to you. Though the question that had come once was describe the three methods of charging. And directly from charging by friction, we are just doing the extreme case so that if in case a question comes, we are prepared. And in your NCRT, there are two, basically these two data are written in your NCRT. This tells us about the glass rod and a silk cloth. Basically, Franklin started his experiments with this only, glass rod and the silk cloth. So when a glass rod is rubbed with a silk cloth, glass rod gains positive charge, silk cloth gains negative charge. And same for woolen cloth, plastic rod. These two things are there in your NCRT, so just have it in your mind. As I told you in the first classes only, you don't have to go through NCRT once we are done in the class. Whatever portions I will tell you, like in your magnetism, like in Safrina's batch, it wasn't. And I told you, no, Safrina table, I'll share with you that part. So that I told you go through NCRT also. Just that part and one or things I'll tell you. Otherwise, you don't have to. Now we'll come on to the numericals. First, take the screenshots and just go through them once. If there's any doubt, let me know. Okay. All right, I hope you all are done by now. Okay, let's come to one numerical. See, now stop writing means once I'll give you time, then you can copy down this part because it's a numerical part you should write by yourself. See what is there in this question. I'm reading carefully, understand, and if there's any difficulty with this, please let me know. Okay, then once you are writing, or I mean have written this, please go through all the screenshots that you have taken and this question so that we can move to the next topic. Okay, but first let us complete this. It says that an object made of substance A is rubbed with an object made of substance B. This is A, this is B. It says A becomes positively charged and B becomes negatively charged. Till this situation, can any one of you tell me which has strongly bonded electrons, A or B, according to the concept that we studied?
B.
B, because it is negatively charged. It didn't allow the electron to move. Definitely there was a stronger bond. So B has stronger bondings than AA. This is what you should know. Next, the question says, however, an object made of certain substance C is rubbed with A. Then A becomes negatively charged. Obviously, B will be the substance C will be positively charged. This is the case. Now compare these two. Now tell me which will have a strongly bonded, more strong foundations.
A.
A, because it is negatively charged. A has stronger foundations than C. Now it says what happens if an object made of substance B is rubbed against an object made of substance C. Basically, this is saying B is there, C is there, B is negative, C is positive. Okay, this was for us earlier. But now it is saying they are rubbed. So we don't know which is positive, which is negative. In order to determine the signs, if I use this data, B has stronger electrons than A, and A has stronger electrons than C. So if I just compare B with C, it means B has stronger electrons than A than C. That clearly shows from this comparison. So now can you tell me the signs of B and C? Yeah,
B is negative and C is positive.
very good. B is negative, C is positive. So easy, simple. These kinds of questions you'll be able to do.
Yes, ma'am.
Charging by conduction, we'll start. Now see, write this question, but whatever we have done, because I know this is a little fast in the batch, we go so slow. You write every point, you have time to comprehend, think, just gather everything. But see, since these are our backup classes and this is not a single chapter, we'll have to do with this only. Okay, this is a little management. You also have to put in a little effort after the class. So write down this question. Once this question is done, just go through once, and if there's anything you want me to repeat or any part, I'll do it. Okay? Please write it, class. Anisa, are you also done? Can we move further?
Yes, ma'am.
Okay. Now, charging by conduction class. What is this charging by conduction? It's similar to charging by friction, very easy, but you just don't move the bodies, you don't wrap them. You just place the bodies either in contact with each other or connect them through a wire. Means charging by frictions theory with the fact that you are just connecting them. You can either connect them through a wire, you can connect them directly in contact. This comes as it is in your sharing of capacitors topic in electric potential and capacitance. So what do you have from this chapter that I'll tell you? From this chapter, you can get the question of finding out the charges on individual bodies. Now, in your syllabus, you will get the identical bodies only. And remember, when you have the identical bodies, the charges are distributed equally. So just use one very simple formula and you will get your answer. The charge, individual charge, the new charge will be Q1 plus Q2 divided by 2. Basically, you add all the charges and then split. It's like if I have something, let's say we have 15 pens. Okay, but we all have in odd numbers. Like it's not 555 with us. Somebody has 4, other one has 5, and the other person will have the other 6. So we have like this 4, 5, and 6. We have distributed it like this. One person has 5, other person has 4, other person has 6 pens. And we want to distribute it equally among the 3 of us. So what we'll do, we'll collect all the pens together. We'll see, okay, these are 15. 6 plus 4 plus 5, these are 15. And how many we are? 3. So we split it into 3 parts. We'll divide it into 3 parts. One for you, one for me, one for her, like this. So similarly here also you're adding the charges and dividing by 2. That's why this is a very easy formula. But remember, this is only valid for identical objects only. Okay? Only identical objects. Like identical means 2 cubes of the same side, 2 spheres of the same radii. Right? Do you get the identical object part? Now let's see this. If this is a body which has a charge 4e and this is a body which has a charge 0, basically this is chargeless, neutral. Now I want to find out after conduction, if they are connected, what will be the individual charges on them. Straight away, 4e plus 0 divided by 2, that is equal to 4e by 2, which is equal to 2e. This will reduce its charge to 4e. This will gain the charge up to 2e. That's it. Got it? Let's take one more example. 4e and minus 8e. So the net charge will be 4e plus, this is minus 8e divided by 2. So this is minus 4e by 2, which is minus 2e. This will reduce to 2e, this will rise to minus 2e. Okay, minus 2e, sorry, both of them will have minus 2e. So the charges will be moving till the time common charge is achieved. The same concept is used in your potential till the time same potential is achieved. But I'll teach you that again, so don't worry. But I'm just telling you that you should have it in your mind that this is important. It will come again. Okay? Am I clear?
Yes, ma'am.
Let's see one question. Easy question. This says that two identical spheres A and B have charges plus 4e and minus 2e. This is A, this is B, and they are identical. So it says a third identical but uncharged sphere. Okay, this is identical but this is uncharged. Identical, the identity part is there, means they have the same radii and we will be able to apply the law of conduction, the charging by conduction. But this is chargeless right now. So it says first it is placed in contact with A. First these two are placed. So class, tell me once they are made in contact, what will be the individual charges on A and C now after connection? 2e. Same thing. We did this example right now. 4e plus 0 divided by 2, that's 4e divided by 2, which is 2e. So this becomes 2e. This also becomes plus 2e. Plus 2e and plus 2e. Now it says the next part of the question, the letter says that it is first placed in contact with A, but then it is placed in contact with B and then removed. Now this is done. But the story isn't over. They too are also connected. Now tell me the net charge on them. 0. Perfect. See, minus 2e and plus 2e, when they'll be added up, they'll be 0. If we use this plus 2e minus 2e, this is minus 2e, this is plus 2e divided by 2, that's 0. So what can I conclude for my answer to this question? Charges on A, B, and C. A, which had the charge plus 4e, is now having the charge plus 2e. B, which had the charge minus 2e, is now 0. And the C object, which had the charge 0 but gained 2e, again lost and 0. So these are our final charges. Will you be able to do the question on charging by conduction? This part? Just remember one very easy formula and you'll be able to do. So take the screenshot till here. Okay. Now copy down this question. Okay, write down this question. Question 2. Okay, coming to the last part, charging by induction. Now, see, in charging by induction, first just hear me out. Here, I have a conductor, and within this conductor, there are certain positive charges and negative charges in equal amount. You can see 10 positive charges, 10 negative charges. So, these positive plus sign represents the positive charges, while this represents the negative charges. So this body is neutral because the net charge is 0. Okay. Now what did I do? I brought a glass rod with positive charges. So what will this positive charge do? It will attract all the negative charges towards itself. Positive will attract negative only. So what we'll observe is that after a period of time, the negative charges are getting attracted. And slowly, gradually, what we'll observe that the positive charges and the negative charges have been separated successfully. So this process of separating the positive and negative charges is known as induction. This whole process is known as induction. Basically, you are inducing charges. We haven't started with magnetism. In magnetism, we'll see, no, we not magnetism, electromagnetism. There a topic induction will come again, self-induction, mutual induction. So this is an important topic, a very important topic. So induction means what happened here? Here there was no charge, like it was neutral. Neutral bodies are everywhere. This was not charged. So we made it negatively charged intentionally. So we are inducing charges which weren't existing. That is what is induction. But there is a limitation class. Advantage is that whenever you want, you can just separate the charges and you can get the desirable charges segregated. But the disadvantage is that till the time I'm holding this glass rod, that time only the charges are separated. If I take the glass rod and let's say I remove this glass rod somehow from here, so what will happen? The negative charge and positive charge, they'll redistribute among themselves and they'll recombine and become back to neutral. It will just reverse. The process will reverse like this. Yeah. If I am holding the glass rod, then only it is able to attract. That's why we say this whole process is a temporary electrification, because you were able to separate the charges perfectly, but it was temporary till the time you were holding the glass rod. And these kinds of substances that are able to separate the charge or induce charges where the charges weren't existing. If you don't see this whole procedure, if I just tell you a neutral object was there, now it has negative charge and positive charge. It's like you're creating charges. From where did the charge come when it wasn't there? Actually, it's just segregation. So the positive charges, these are called the inducing charges. While the segregated charges, they are called induced charges. Okay. Now, there's a concept of earthing that we'll study later. This is the same thing. Earthing basically means, because there is a question in your NCRT solved example, or I think in the back, I'm forgetting. From this induction part. So that involves a little bit knowledge of earthing. What exactly is earthing? If you have any conductor, anything that has charges, you connect it to the earth surface. Let's say I've connected it to the earth like this. This is the symbol for earthing. So what happens? See, earth is very big, very big. It can accommodate many electrons beyond your scope. Okay, we cannot even think of how many electrons can be accommodated within the core of the earth, right? So what we do, if we connect anything, let's say I have excess of charge. If we just pass on it to the earth, there is only the only possibility where our charges could be stored. If I have something which can store charges, that's fine. But what if I have many charges that cannot be just stored? So that's why everything is just sent through the earth. Like, see, whenever you get an electric shock, mostly this occurs in your elbow. When you strike something very quickly, don't you feel a current like sensation in your ulnar nerve? Basically, that nerve that is present there. So it's like an electric current is flowing, right? And when you actually experience the currents, means electrons are actually there in your body. So what happens is your body will act as a conductor because human body is a conductor. So all the excess electrons pass through your body to the earth surface. Okay, so how to decide whether the electrons will go from earth to body or body to earth? You just see this. Negatively charged body, electrons move from the earth, from the body to the earth. And if it's a positively charged body, earth to the body. Though this we'll see in potential, here the potential becomes zero and all, lots of things will come. Now the question, what kind of question was there? The question basically said that you have to make this isolated charged sphere as completely positively charged. Means right now this is neutral. This has no charge. You have to make it positively charged. So what we'll do, let's say this is put on an insulating stand so that the charges do not go off. This is the insulating stand and this is the conductor that we have. Now this must have the positive charges and the negative charges because right now it's neutral. So what I'll do, because I want the positive charges to retain, I'll bring a negatively charged glass rod so that positive charges can be attracted. This is negatively charged glass. So due to which what will happen? All of the positive charges will soon be attracted towards it. So this is how we're holding the negative charges. Positive charges will be attracted towards this side and the negative charges will be left on the other side. Like this. That's what we studied. Now, here if I just do a small thing, now problem is that if I remove this glass rod, they'll become back to the original state, they'll just recombine. So if I perform earthing here, what will happen? All of these electrons from here, they will slowly go to the surface of Earth. So what will I be left with? I'll be left with this. This is the globe of the conductor. This is the insulating stand. Here I am holding up the glass rod, which has negative charges and positive charges are being attracted. But there aren't any negative charges to fear. So what I'll do now, I can easily remove this. If I just remove this, if I remove the glass rod, what will happen? Only positive charges are there. There are no negative charges to recombine. So what does it give me? It gives me a positively charged sphere. Is it clear to both of you, Anisha and Safina?
Yes, ma'am.
Okay, take the screenshot and write down the question, okay? All right, class. Now please start copying down this question. Can we go further? Anita, you're also done?
Yes, ma'am.
Okay. Just few more points, class. The rest of it I'll do it in the next class. Regarding various properties, so only three properties I'll discuss with you today. Properties of electric charges. First property, very simple, very easy. Additive property. See, charges are scalar. They don't need special vector addition or anything. So when you have to find out the net charge, you can just add all of the charges. For an example given, plus 2 coulomb minus 3 coulomb plus 4 coulomb. If I want to calculate the net charge, I can simply say plus 2 coulomb minus 3 coulomb plus 4 coulomb. That is equal to 3 coulomb. So I didn't need any vector law or anything else. You can simply add using your usual algebra. Reason behind is that charges are scalar. That's it. Scalar means you can use the algebraic addition. That's the first point. Second, conservation of charges. I think we did this a lot and in depth and in detail we did the conservation of charges, right? So conservation of charges mean that charges can neither be created nor be destroyed. They are just transformed from one body to another body. This is what we've studied. This is actually the second point, and this is third point. Charges do not depend on speed. Okay. Masses, there's a formula of mass in your NCRT class 11. M is equal to m naught divided by under root 1 minus v square by c square. If you have ever looked upon this formula, in one of your additional questions, this was there in laws of motion chapter. Basically, this tells us how mass and speed are related to each other. But the problem with charge is that charges do have mass. But the problem is that the speed is so fast that the denominator becomes negligible and their mass will be zero then. That's why the charges do not depend on the speed. You increase the speed, you decrease the speed, whatever. Charge will remain as it is. Am I clear with these three facts? Both of you?
Yes.
Okay, all right. Please write down it. Or you can take the screenshots also for these three. You can write it later. Just take the screenshots.
Ma'am, can you please explain the third property?
Yes, see, third property, this is basically known as the rest mass. This mass is known as the rest mass. Rest mass means when the object is at rest, what is its mass? So the formula of the mass is given by rest mass divided by under root of 1 minus v square by c square. You don't have to remember this, I was just telling you for an explanation because this formula was already mentioned in your class 11th chapter. Okay,
Okay.
so mass depends on speed. But when we talk about charges, see, charge also has its mass. We discussed. But the
Yes,
problem
ma'am.
is that the speed is so much that it is almost equal to the speed of light. C is the speed of light, V is the speed. So if I say this is also C square will be 1, under root 1 minus 1 will be 0, 1 by
Yes.
0. This will be infinity, means that there won't be any mass of the charge. But that's not possible. So it means it is not following this formula where mass is following the speed. So this formula isn't valid. Charges are independent of the speed. Okay. So this
Yes,
you
ma'am.
don't
Thank
need to
you.
remember, just have it for your reference.
All
Okay.
right, ma'am.
Done both of you, Anisa and Safrina.
Yes, ma'am.
Okay, so see, write it down in your registers. Please don't rely on the screenshots. I'll tell you, even one of them gets misplaced, it will be difficult for you, and you don't know which topic comes in the exam. Anything can come, and if we are doing it in detail, you should also write it so that while writing,